Question number 1, find the inverse f for each of the following one-to-one functions. So before we start, let's look at the arrow diagram that I have here. So the x here is the object for the f and y is the image. So therefore, the f of x is equal to y. So for the inverse of f, it will be equal to x. So we're going to use these relationships to help us to solve for the inverse of f. So let's look at the questions A here. The f of x is equal to 2x minus 5. So first, using the relationship that we have here, let the inverse of y equal to x. Therefore, the f of x will be equal to y. So the fx here is equal to 2x minus 5. So I'm going to replace it for the fx here. Next, we're going to let this x to be the subject of the formula. So therefore, I'm going to move this negative 5 to the other side. So it will become y plus 5. So next, x is equal to y plus 5 divided by 2. Now, the x here is equal to the inverse f of y. Therefore, the inverse f of y is equal to y plus 5 over 2. Now, I want to find the inverse f of x. Therefore, I'm going to replace the y here with the letter x. So it will be x plus 5 over 2. So this is the inverse f of the questions of A. So now we're going to move to questions B. The functions f of x is equal to 3 over x. So let us write the relationship first. So let's the inverse f of y equal to x. Therefore, the f of x will be equal to y. So the fx here is equal to 3 over x. So now let's the x to become the subject of the formula. So I'm going to move the x to the other side. It will become 3 equal to xy. Then I'm going to move the y to the other side here. So x is equal to 3 over y. So the x here is referred to the inverse f of y. Therefore, it will be equal to 3 over y. Now I want to find the inverse f of x. So the letter y here, we're going to replace it with x. So it will be equal to 3 over x. So in this case, the x cannot be 0. So that is for questions B. Now let us move to questions C. So the functions f of x is equal to 4 over x minus 1. So first, let the inverse f of y equal to x. Therefore, the f of x is equal to y. So the fx here is equal to 4 over x minus 1. Now I'm going to move this x minus 1 to the other side. So it will be y multiply the x minus 1. Now to let the x to become the subject of the formula, so I'm going to move this y to the other side. So you're going to have 4 over y equal to x minus 1. Later on, I'm going to move this negative 1 to the other side. So it will be x equal to 4 over y plus 1. Now, to make this into a single fraction, first I need to equalize the denominator. So this is 1 over 1. So I'm going to multiply it by y here. So therefore you're going to have 4 plus y over y. Now the x here is referred to the inverse f of y. Therefore the inverse f of y will be equal to 4 plus y over y. Now to find the inverse f of x, then we're going to replace the y here with the x. So it will be 4 plus x over x. The x here cannot be equal to 0. So questions D. So the functions f of x here is equal to 5x over x minus 6. So first, let's the inverse f of y equal to x. So therefore, the f of x will be equal to y. So in this case, the fx is equal to 5x over x minus 6. Next, we're going to let the x to become the subject of the formula. So we're going to move this x minus 6 to the other side. Next, we're going to do the expansion. So we're going to have xy minus 6y. So next, we are going to move the x into one side. So I'm going to move this 5x to the other side, and this minus 6y to another side. So next, I'm going to have 6y equal to xy minus 5x. So for this side, I can do the factorizations because I have the common factor x here. So bracket y minus 5. So now, to let the x to become the subject of the formula, we move this y minus 5 to the other side. So it will be 6y over y minus 5. Now this x is equal to the inverse of y. So therefore it will be equal to 6y over y minus 5. Next, to write the answer in the inverse f of x, then we're going to replace the y here with the x. So you're going to have 6x over x minus 5. And in this case, the x cannot be equal to 5. Now, I want to draw your attention to this step here. From here, we can also move this xy to the front, right? If we do this, the next step that we're going to have here is 5x minus xy equal to negative 6y. So here we can also do the factorizations. So you are going to have 5 minus y equal to negative 6y. Now next, the x will be negative 6y over the 5 minus y. So now if you compare these two x here, they are different, right? So for the answer in the textbooks, it will only return the answer of the y with the coefficients of the positive ones. So if this is the ones that you do, this still considered as a correct answer. So for the questions E and F later on, so we are just going to discuss the answer of the y with the coefficients of positive. So now questions E. The f of x is equal to x plus 9 over x minus 8. So first, let's the inverse f of y equal to x. Therefore, the fx equal to y. So fx is equal to the x plus 9 over x minus 8. So next, move the x minus 8 to the other sides. Then we're going to do the expansions. Next, we are going to collect the x into one side. So here I'm going to move the x to this side and then this minus add y to the other side. So I'm going to have next 9 plus add y equal to xy minus x. So for this parts here, I can factorize. I have the common factor of x here, so y minus 1. To let the x to become the subject of the formula, so it will be 9 plus add y over y minus 1. So remember, the x is referred to the inverse f of y. So therefore, it will be equal to 9 plus add y over y minus 1. Now, to write the answer of the inverse of f of x, then we're going to replace the y here with the letter x. So in this case, our x cannot be equal to 1. So now we're going to move to questions f. So the f of x is equal to 2x minus 3 over 2x minus 1. So first, let's the inverse f of y equal to x. Therefore, the f of x will be equal to y. So fx is the 2x minus 3 over the 2x minus 1. Next, move this 2x minus 1 to the other side. So for this part, just do the expansions. So you're going to have 2xy minus y. Next, we are going to collect the x into one side. So for this case, I'm going to move this 2x here and then this minus y to the other side. So next, I'm going to have negative 3 plus y equal to 2xy minus 2x. So this one I can rearrange it. So it will be y minus 3 equal to, so do the factorizations for this part because we have the common factor of x here. So x brackets 2y minus 2. To let the x to become the subject of the formula, move this one to the other side. So it will be y minus 3 over 2y minus 2. So remember, the x here is the inverse f of y. So therefore, it will be equal to y minus 3 over 2y minus 2. Now, to write the inverse f of x, then we're going to replace the y here with x. So in this case, the x cannot be equal to 1. Because if the x is 1, then you're going to have 2 minus 2, which is 0. So question number 2. The functions f is defined by f maps x to 3 minus x over 2x. So A, find the inverse f of 4. So first, we're going to find the inverse functions of the f. So first, f of x is equal to 3 minus x over 2x. So let the inverse f of y equal to x. Therefore, the f of x will be equal to y. So fx is equal to 3 minus x over 2x equal to y. Now we're going to let the x to become the subject of the formula. So move this 2x to the other side. So it will be 2x multiply y, which is 2xy. Now we want to move, we want to collect the x on one side. So move this minus x to the right. So you're going to have 3 equal to 2xy plus x. So on the right hand side, we can do the factorizations here because we have the common factor of x. So x brackets 2y plus 1. To let the x become the subject of the formula, move this 2y plus 1 to the other side. It will be 3 over 2y plus 1. So the x here is referred to the inverse f of y. So therefore, the inverse f of y is equal to 3 over 2y plus 1. So to write the inverse f of x, then we're going to replace the y here with the letter x. So in this case, our x cannot be negative 1 over 2. So if the x here is a negative 1 over 2, so when you multiply it with 2, it will give you the answer of negative 1. Then when it plus 1, then it will be equal to 0. So now we already have the inverse of f. Now we can find the value of the inverse f of 4. So the x here, we're going to replace it with 4. So you're going to have 2 bracket 4 plus 1. So here it's going to give the answer of 3 over 9. So when you simplify it, it will give you the answer of 1 over 3. Now we're going to move to questions B. So find the values of x such that f of x is equal to the inverse f of x. So fx is this one, which is 3 minus x over 2x. So the inverse of x is the one that we find here, which is 3 over 2x plus 1. Now next, we're going to do the cross multiplications for these parts. So first, when 2x multiplied by 3, you're going to have 6x. And for this side, this is 3 minus x multiply 2x plus 1. So this one, you're going to do the expansions. So 6x is equal to, so the first one, 3 times 2x, 6x. Later on, plus 3 minus 2x squared and minus x. So if you look at here, this is a quadratic equation as the highest power of x is 2. To find the value of x, so first, write these equations in general form. So on your left hand side, you have a positive 6, and on the right hand side, you also have a positive 6. So therefore, we can cancel out this 6x here. So we want the a of our x squared in positive form. So therefore, we're going to move everything to the left hand side. So next, you're going to have 2x squared plus x minus 3 equal to 0. So for this part, we're going to do the factorizations. So you're going to have 2x plus 3. So another bracket is x minus 1 equal to 0. So this means 2x plus 3 equal to 0 or x minus 1 equal to 0. So here x will be equal to negative 3 over 2 or x is equal to 1. So question number 3, given the function h maps x to 4x plus a and the inverse of h maps x to 2bx plus 5 over 8. So find the value of the constants a and b. So the inverse of h given here is when this function h, you inverse it. So to find the a and b, so I'm going to inverse this function h. Then later on, we're going to do the comparisons with the inverse of h given in the questions. So first, let us do the inverse of the function h. So first, let's the inverse of h of y equal to x. Therefore, the h of x will be equal to y. So the hx is the 4x plus a. Later on, we're going to let the x here to become the subject of the formula. So 4x is equal to y minus a. So x is equal to y minus a over 4. So the x is the inverse of h of y. So therefore, the inverse h of x, then we are going to replace the y with the letter x. So we can also subtract the single fractions that we have here. So it will become x over 4 minus a over 4. Now we are going to compare this with the inverse of h given in the questions. So now first look at this 2b. This is the coefficients for the x. So we are going to compare it with the coefficients for the x that we have here. So the x here, the number at the front will be 1. So therefore the coefficients for the x is 1 over 4. So by doing the comparison, so we can set that 2b is equal to 1 over 4. Now to find the b, going to move the number 2 to the other side. It will be 1 over 4 divided by 2, which is equal to 1 over 4 multiplied by 1 over 2. Therefore, the value of b is equal to 1 over 8. Then we're going to do the comparison next. The number, this 5 over 8, is equal to this negative a over 4. So, negative a over 4 will be equal to 5 over 8. Now, to find the a, we're going to move this negative 4 to the other side. It will be 5 over 8 multiply negative 4. So, simplify this one. So, next you're going to find the a is equal to negative 5 over 2. Question number 4. Find the functions f in similar form for each of the following inverse of f. So this question asking you to change this inverse of f to the functions f. So first look at the arrow diagram that I have here. So based on the inverse function given, the x is the object of the inverse functions. Therefore, the x will be on the right hand side, which means the y will be on your left hand side. Therefore, we can set the f of y is equal to x and the inverse f of x is equal to y. So we're going to use these two relationships to help us to solve for the a, b, c. So first let us look at a. So the inverse f of x is equal to 6x plus 7. So first using this relationship, so let's the f of y equal to x. Therefore, the inverse f of x will be equal to y. So the inverse f of x is this 6x plus 7. Next, we're going to let the x to become the subject of the formula. So 6x is equal to y minus 7. So x is equal to y minus 7 divided by 6. So the x here is the functions of f of y. So therefore, the functions f of y equal to y minus 7 over 6. So the f of x, then later on we're going to change the y to x. So this is the functions f for a. Now we're going to move to b. So the inverse f of x equal to 2 minus x over 5. So first, let the f of y equal to x. Therefore, the inverse f of x equal to y. So the inverse f of x is equal to the 2 minus x over 5. Next, we're going to let the x to become the subject of the formula. So move this 5 to the other side, become 5y. Next, I'm going to move this negative x here and the 5y to the other side so that our x will be in positive form. So 2 minus 5y equal to x. The x is referred to the functions f of y. So therefore, the function f of y is equal to 2 minus 5y. To write the function f of x, then we are going to change the letter y here to x. So this is for the questions B. Question C. The inverse f of x is equal to 3x over x minus 3. So first, let the f of y equal to x. Therefore, the inverse f of x is equal to y. So the inverse f of x is equal to this. Therefore, 3x over x minus 3 equal to y. So now we're going to let the x to become the subject of the formula. So 3x is equal to y multiplied x minus 3. So expand it, you're going to have xy minus 3y. So in this case, later on, I'm going to move this x to one side and this negative 3y to the other side. Next, you're going to have 3y equal to xy minus 3x. For your right hand side, we can do the factorizations because x is the common factor here. So x equal x bracket y minus 3. So x is equal to 3y over y minus 3. So the x is equal to the f of y. So therefore, the f of y is equal to 3y over y minus 3. So the f of x, then we're going to change the y to x. So 3x over x minus 3. So in this case, our x cannot be equal to 3. So question number 5, the inverse function g is defined by the inverse of g maps x to 4 over 2 minus x. The x is not equal to k. So A state the value of k. So we know that the x is not equal to k. So now look at this denominator part. So this part here cannot be equal to 0. Therefore, the x is not equal to 2 because when you have 2 minus 2, then it will be equal to 0. Therefore, the value of k here is equal to 2. So next, we're going to find the questions B. So find the g of 1 over 2. So in this case, the inverse of g has been given to you. Now, you can use the method in questions 4 to change this inverse of g to g. Later on, you're going to input the 1 over 2 into the g to find the answer. Or you can also use another method. So let us draw the arrow diagram here first. So this is the g and this is the inverse of g. So this 1 over 2 here is the object of the g. So this 1 over 2 will be here. So we want to find this 1 over 2 will be mapped to another number which we didn't know now. So let us label it as a. So therefore, we can set the g of 1 over 2 is equal to a. And the inverse g of a is equal to 1 over 2. So we're going to use these two relationships to help us to solve for the questions B. So first, let the g of 1 over 2 equal to a. Therefore, the inverse g of a will be equal to 1 over 2. So we already have the inverse of g here. If you label it, if you have the object a here, then we're going to change the x that we have here to a as well. So next, we're going to have 4 over 2 minus a equal to 1 over 2. So next, we're going to do the cross multiplications here. So therefore, next we're going to have 4 times 2, which is 8. And this part, 2 minus a times 1 is still 2 minus a. Now to find the value of a, so I got to move these negative a's to the front and this number 8 to the back. So next you're going to have a equal to 2 minus 8. Therefore, a is equal to negative 6. So the a is equal to the g of 1 over 2. So therefore, the g of 1 over 2 is equal to negative 6.